Have you ever stood still and wondered if the ground beneath you is truly solid? It might feel unmoving and permanent, but the reality is far more fascinating than it appears at first glance. It's not. The Earth's surface is on a slow, epic journey, constantly shifting and changing over millions of years. Right now, the continents are drifting, moving at about the speed your fingernails grow, just a few centimeters each year, but over time, this adds up to incredible distances. This movement, called plate tectonics, is the powerful force that builds towering mountains, triggers devastating earthquakes, and fuels fiery volcanoes across the globe. The continents are like giant rafts, gliding across the planet's surface carried by invisible forces deep within the Earth. Imagine Africa inching ever closer to Europe or Australia slowly drifting northward, reshaping the map of our world. This isn't science fiction, it's the reality of our living, breathing planet, always in motion beneath our feet. Deep inside the Earth, intense heat creates powerful currents that push and pull the continents, ensuring our world is always changing and evolving. Understanding this movement unlocks secrets about our planet's past and future, revealing how continents have collided and separated over eons. It explains why similar fossils are found on continents now separated by vast oceans, and why earthquakes and volcanoes strike certain places more than others. The continents never stop moving. The forces that set them in motion billions of years ago are still at work today, shaping the land beneath us. So, let's journey into the science of plate tectonics and discover why our planet is always alive and shifting, never truly at rest. We'll uncover the hidden engine that drives our continents and see how this constant motion shapes our world, influencing everything from landscapes to life itself. To understand why continents move, picture Earth's surface as a cracked eggshell. Imagine the shell isn't one solid piece, but instead is made up of many fragments, each with its own shape and size. The outer layer, called the lithosphere, is broken into tectonic plates, massive slabs of rock that float on a softer, almost plastic-like layer beneath, known as the asthenosphere. This allows the plates to move, even if only a few centimeters each year. Some plates carry entire continents, while others support only the ocean floor, but all of them fit together like a gigantic, ever-shifting jigsaw puzzle that covers the globe. There are about a dozen major plates, including the Pacific Plate, the largest, and the North American Plate. Each plate has its own boundaries and interacts with its neighbors in unique ways. These plates are always moving, grinding past each other, pulling apart, or colliding with tremendous force. This constant motion shapes the surface of our planet. This movement is called continental drift, and it's the reason why the world map has changed so dramatically over millions of years, with continents slowly drifting to new positions. The idea was first proposed by Alfred Wegener, a German scientist who noticed that the coastlines of South America and Africa seemed to fit together perfectly, almost like two pieces of a puzzle separated by time. Wegener also found matching fossils and rock types on continents now separated by vast oceans, suggesting they were once joined together in a supercontinent called Pangaea, sharing plants and animals across what are now distant lands. At first, many scientists doubted him. After all, what force could possibly move entire continents across the globe? The idea seemed impossible at the time. But over the years, evidence grew stronger. A vast mountain range in the Atlantic, mysterious magnetic stripes on the ocean floor, and precise GPS mapping all showed that plates really do move, and continue to do so today. Today, plate tectonics is the foundation of geology, explaining how Earth's surface is built, destroyed, and rebuilt again, creating mountains, valleys, and ocean basins. The continents are just passengers on these restless plates, carried along for the ride as the plates shift and change direction. The forces that move them are still active, shaping our planet every day through earthquakes, volcanic eruptions, and the slow rise of mountain ranges. Our world is a dynamic puzzle, always shifting and changing, with continents drifting apart and colliding over millions of years. Understanding these plates helps us see the Earth as a living, evolving system, one that is constantly in motion, shaping the land beneath our feet and the world we call home. What moves these gigantic plates? The answer lies deep inside Earth. Earth's layers are like an onion, a hot iron core, a liquid outer core, and a thick, slowly flowing mantle. The mantle's movement, called mantle convection, is the engine of plate tectonics. Heat from Earth's formation and radioactive decay warms the mantle, causing hot rock to rise and cooler rock to sink. These convection currents act like conveyor belts, moving the plates above. Where hot mantle rises, plates are pushed apart, and new crust forms, like at the mid-Atlantic ridge. Where cooler mantle sinks, plates are pulled down in subduction zones, creating deep trenches and volcanic arcs. This planetary heat engine has been running for billions of years, slowly but powerfully reshaping our world. The movement is slow, just centimeters per year, but over time it builds mountains, opens oceans, and rearranges continents. We may not feel it, but this silent force is always at work. Plate tectonics is the reason Earth is never the same from one era to the next. The real drama of plate tectonics unfolds at the boundaries where massive plates meet and interact. These invisible lines beneath our feet are where the Earth's restless energy is released, shaping the world in ways both subtle and spectacular. There are three main types of plate boundaries: divergent, convergent, and transform, each with its own unique set of processes and consequences for the planet. At divergent boundaries, plates slowly move apart, allowing magma from deep within the Earth to rise and solidify, creating new crust. This process is constantly at work along places like the Mid-Atlantic Ridge, which is gradually widening the Atlantic Ocean and reshaping continents over millions of years. Sometimes this dramatic process happens on land, as in the East African Rift. Here the continent is literally splitting apart, and one day, a brand new ocean may form, forever altering the map of Africa. At convergent boundaries, the action intensifies as plates collide head-on, unleashing immense forces. When an oceanic plate meets a continental plate, the denser oceanic plate is forced beneath the lighter continental plate in a process called subduction. This forms deep ocean trenches, triggers powerful earthquakes, and fuels explosive volcanoes, just like those that line the Andes Mountains in South America. When two continental plates collide, neither wants to sink. Instead, they crumple and fold, pushing up the land to form some of the world's tallest and most awe-inspiring mountain ranges, such as the mighty Himalayas. Transform boundaries are different. Here, plates grind past each other horizontally, like the famous San Andreas Fault in California, creating a jagged scar across the landscape. At these boundaries, crust isn't created or destroyed, but the relentless grinding motion builds up enormous stress along the fault lines. When that stress is finally released, it sends shockwaves through the ground, causing earthquakes that can reshape entire regions in moments. These boundaries are the birthplace of Earth's most dramatic features and the source of its most powerful natural disasters: volcanoes, earthquakes, and towering mountains. The movement of the plates is relentless and unstoppable, constantly shaping landscapes, coastlines, and even the lives of people who live near these dynamic zones. Every mountain, trench, and earthquake is a chapter in the ongoing story of plates in motion, a story written over millions of years. Our planet's surface is a constantly shifting mosaic, with continents and oceans always on the move, even if we can't see it happening. The boundaries are where the action and the danger happens, reminding us of the immense power locked within the Earth. By studying these boundaries, scientists can better predict and prepare for Earth's most powerful events, helping to protect lives and property. Plate boundaries are the front lines of our ever-changing world, where the forces that shape our planet are most visible and most intense. They remind us that the ground beneath our feet is never truly still, and that our world is and always will be a world in motion. The idea of drifting continents began with clues from maps and fossils. Matching coastlines and identical fossils on distant continents suggested they were once joined. Ancient glaciers in now tropical places and coal in Antarctica only made sense if continents had moved. Today, technology gives us direct proof. GPS and satellites track the movement of Earth's crust with millimeter precision. We can see continents shifting, earthquakes deforming the ground, and even measure the distance between continents changing. All this data confirms what fossils and rocks hinted at. The ground beneath us is moving right now. Plate tectonics is not just a theory, it's a measurable, ongoing process. Our planet's restless surface is a journey we can now watch in real time. In 2025, the continents are still on the move. The Atlantic Ocean widens as North America and Eurasia drift apart, while the Pacific shrinks as its plate subducts beneath others. This fuels the Ring of Fire, an arc of earthquakes and volcanoes around the Pacific. Major earthquakes in Japan, Chile, and Turkey, and eruptions in Iceland and Hawaii are all signs of active plates. Scientists use computer models to predict future supercontinents like Pangaea Ultima, where the Americas might collide with Africa and Eurasia. Australia is moving north, Africa is pushing into Europe, and the map of Earth is always changing. These changes are slow, but their effects are dramatic. The continent's journey is far from over. Should we worry about moving continents? Not in the long term. The changes take millions of years. The real danger comes from sudden events at plate boundaries, earthquakes, volcanoes, and tsunamis. For people in active regions, these hazards are a real threat. But science and engineering help us prepare. Monitoring systems, early warnings, and earthquake-resistant buildings save lives. Public education and emergency plans are crucial for safety. We can't stop the plates, but we can adapt and protect ourselves. Human ingenuity reduces our vulnerability to these powerful forces. Plate tectonics is awe-inspiring, but with preparation, we can live safely on our restless planet. Understanding plate tectonics is vital for safety, resources, and our view of Earth. It helps us map hazards, enforce building codes, and plan for disasters. Plate boundaries concentrate valuable minerals and create conditions for oil and gas. Studying shifting continents reveals the story of life's evolution and explains unique biodiversity. Plate movements shape climate and ocean currents, influencing Earth's long-term habitability. This science even guides our search for life on other planets. Plate tectonics may be a key ingredient for a habitable world. By understanding our dynamic Earth, we appreciate the rare conditions that make life possible. Plate tectonics shows us that Earth is always in motion. From new ocean crust to towering mountains, these forces shape our world. Change is the law of the universe, and our planet is a masterpiece in progress. The same forces that cause disasters also create beauty and resources. We are passengers on this restless Earth, learning to adapt and thrive. The story of shifting continents is our story, guiding evolution, migration, and culture. Understanding our connection to Earth gives us perspective and respect for its power. The continents will keep moving, redrawing the map for eons to come. By studying our ever-changing home, we protect ourselves and marvel at the wonder of our living planet. Earth's shifting surface is a reminder of our place in a vast, dynamic story.